Okay, hi. So we're starting a new chapter, Introduction to Statistics, and I am so sad that we're not at school for this. This is one of my favorite and funnest sections because we get to do a lot of group work, and we get to, anyway. So I'm really sad that we're not there, and I'll try to think of if I can find some fun way that we can do this. I don't know. Maybe you guys will make a good Google form and we can send them out to other people. I don't know, but we'll see. So let's go ahead and let's look at how can we, oh, let me put this in presentation mode. That'll just be better, right? From beginning, there we go. That looks nicer. Okay, how can you represent numerical data and use them to answer statistical questions? Now, we have discussed this a little bit in the do-nows when it would ask us if some statement was statistical or non-statistical. So we have done something kind of like this. There we go. So this shouldn't be completely new to you. Statistical questions can be answered by collecting and tabulating data. So is it something that you can collect data on and tabulate things from? And then can I make a histogram or a dot plot or bar graph or something? Can I represent it graphically? And here it suggests dot plot or a histogram. And once again, we're back to this. The central question of this chapter is how can I represent numerical data and use them to answer statistical questions? And it's not always the best idea to use a dot plot and a histogram. They're not really interchangeable. They have very specific purposes in the types of data that they represent. Okay, so it's a very important distinction. Today we're going to talk more specifically about dot plots. Let's see, we're going to just keep, and we're going to go to this other one. We're going to go through two PowerPoints today because I want to try to get through this, and so that those of you that are, anyway, another day, another conversation. All right. So what we have here is Sean conducted a survey to find out the shoe size of some classmates. Their shoe sizes are as follows. So I want you to take some time, if you want to pause this video or whatever, to consider ways that you could organize this data and then how you could represent it so people could just give it a quick glance and they'll know like kind of where the median and the mode would be and the mean. They could get an idea based on your graphic representation of this data. All right, next part is the number of texts sent by some students in a day are as follows. These numbers are incredibly low, I believe, but it's depending on the student. So it says that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like there's 10 students here. And so each one of these numbers represents how many texts that student sent out. Okay, now what I would do, and it shows this later, but I don't like that it's on a separate slide. So I'm just going to draw a very crude one here. So I'm going to draw a dot plot. Let's at least try to get a straight line. Yikes. Okay. Better. Okay. So first thing I want to do when I'm going to create a dot plot is I need to organize my data so I know what plots, numbers I need on there. So I would organize it from least to greatest. So I would put 10, and then it looks like we have 3 11s, but I'm gonna represent that 3 times. Okay, and then I've got 2 12s. And if it helps when you're doing this, like in your workbook, if it helps to cross these numbers out as you write them, because look, just doing that, I discovered another 12. Okay, and then we've got 1 13, and then 2 15s. Okay, so I can see that my low end is 10, my high end is 15. So So I would create my dot plot like this, and maybe I wouldn't have them sticking above the line here. So maybe I'll do another line on top of that so we can make the little dots above it. Okay, so this is going to be 10, 11, 12, 13. We might even represent the 14 in here, and 15, even though there are no numbers that are that. Okay, so then we come back up to our data, and we're going to put a dot however many times that number, how many times a student sent 10. And there was only one student, so there's one dot. Here we can see there's 3 students. So I would do 3 dots. Then I go to the next one, same thing here. Excuse me. And then I have 1 in the 13. Excuse me. And then I have nothing for 14. And then 15 I have 2. So that would be a completed dot plot. I have taken care of all my numbers. I have created a range which is suitable for my data set. Okay, so let's go on and see what they suggest that you do. Oh, let's erase this. You don't need that in your way. Okay, so the first thing they suggest that you do is that since the number of text messages are from 1 to 15, draw a horizontal number line that extends from 10 to 15, sorry. And then list the numbers sequentially with the same spacing on the number line. So just like I did, make it as even as possible. Anytime we draw number lines, right? We draw like that. Space them evenly. Okay, and then there they put in the dots, just like we did. Okay, each dot represents 1 student. Okay, so the numbers at the top here, the numbers at the bottom represent the number of texts. Lovely. So this is the number of texts here. And then each dot is a student. So there is 1 student that sent 10 texts. There are 3 students that each sent 11 texts. Okay? And then 3 students that sent 12 texts each. All right? And so forth. There might be a time where they ask you to add up how many texts were sent. What is the average? In that case, you would just total up, So here there were 33. Here there were 36, right? 13 and 30. And then you would add that all up and then divide it by the number of students, and that would give you the average number of texts that were sent out. Okay? Let's see, moving on. Since the data value 10 appears once, 1 dot, 11 3 times, and so forth, okay? Since she says that the data value 14 is absent, so there is no dot above that number. All right, so June tossed a number cube. That's a dice. Numbered 1 to 6, right? A dice. She tossed it 20 times. Now this is an activity that we would have done in class if we were there. We would have done 3 sets of this data, and then we would have compared the different sets to see if there was any consistency in that, or if it really is just random. Okay, so she recorded it on the numbers on a table below. So represent this data on a dot plot. So here you can see that this is the number of times that she rolled the 1 in 20. If we added up this frequency, this adds up to 20. Okay, so of her 20 rolls, 2 times she rolled a 1, 3 times she rolled 2, 6 times a 3, once a 4, 5 times a 5, and 3 times a 6. Okay, I'm going to go forward, see if they do the dot plot for us. Okay, let's see, sorry. Yeah, they do. But I'm going to draw it so you could see here. So you would draw your number line, and you're going to go from 1 to 6. So 1, 2, 3, 4, 5, 6. If I had an eraser, I'd get rid of that. So you're going to label 2, 3, 4, 5, and 6. And then dots above. 2 dots on the 2, 3 dots on the 3. You're going to have lots, right? And 4, you're only having 1, and then 5, another 5 would be, and then there we go. Okay, so this is what the dot plot would look like that you draw. Now let's look at the one they draw, because they're fancy, right? They do theirs with a computer, so it's perfect right there. Okay. I think next what we're going to talk about is, just some food for thought here. Food. Okay. Mr. Wilson accidentally spilled coffee on the dot plot below. Oh my goodness, silly Mr. Wilson. How could he do that? Okay. What do you think this data set represents? Share and justify your ideas. Okay. So share with your mom or whoever's sitting next to you, or your cat, whoever. What do you think this could represent? Okay. So I'm going to go with coffee. I'm going to say how many people in a month spill their coffee. So there are 1, 2, 3, 4, 5, 6 people who admit that 8 times a month, on average, they spill their coffee. Okay. And then there's this person up here, 10 times. Wow, he's really clumsy. Okay, so it could be really represent anything you wanted it to be. There's no right or wrong on that. All right, next slide. Okay, so let's interpret data from a dot plot. Here, some things we've already discussed. The range, okay? It ranges from 1 to 7, okay? So we talked about how you subtract, you find the difference between those two. So that means you would have a range in this of 6, right? Goes from 1 to 7. If you look at this, if you follow it, that's terrible, but it's okay. You can see how it's very symmetrical, right? Here's the dividing line, 2, 2, 1, 1 on both sides. Very symmetrical data in this particular dot plot. So let's see. Like I said, it is very symmetrical. Now, all your data is not going to be symmetrical, and you can see that the majority of the data is centered right here, right in the middle of the data range. Sometimes you'll have a dot plot that looks like this, that goes off to the left, like this. So here is the largest amount of data here, and it's going off to the left. Okay, so this would be an example of something that is left skewed. Okay, a data set that is, the data is left skewed. So here's the biggest one, and then everything, and then it just kind of drops off here. Okay, our next one is going to be an example of something that is, what is going on here? It doesn't want to. Let's see, let's go to the next slide. Okay, there we go. Our next one here is completely the opposite, right? Our data is going this way, right? Trailing off to the right. So in this case, this data would be right skewed. okay? Because here's the majority of my data here, and then it trails off to the right, right? Most of it is going to the right. So the data is skewed to the right, which means that most of it is to the right of the largest set, the biggest number. In this case, let's see. So let's go to the next slide. Okay, all right, skewed. So here we have some data that we can interpret. The monthly savings of 15 students is shown on the dot plot below. Okay, so would you say that this is symmetrical? Would you say that it's left skewed, right skewed? I believe that if I had to choose any of them, it kind of follows this. I'm going to say that it is symmetrical. This is more symmetrical than skewed to the right or to the left. Okay, and then another little point is that this right here, this dot over here, that is what we call an outlier. Okay, these two things, a lot of times your outlier is going to be like way over here, okay, but not always. But any data that lies away from the rest of the data set is considered an outlier. And usually, like I said, those are way out here, not just a couple, 3 points. You be like 10, 20 out, okay? All right, let's go ahead to the next slide. Is that nearly symmetrical, centered around 20. So they're giving you ways to describe the data plot. So this data plot is nearly symmetrical. Okay, it's not completely symmetrical, it's nearly symmetrical. And the majority of the data is centered around 20. Okay, and it even goes further, saying that the most data values are from 19 to 21. So even giving you more information of where most of the information lies. Okay, and then it had a range, and we've talked about range before, that difference between the lowest data point and the highest data point. So this particular dot plot had a range of 7. Okay, I just said that. The range of a set of data is the difference between the greatest and the least value. Okay, what can you, from our monthly savings, what can we say? That they typically saved $19 to $21, but their savings range was anywhere from 17 to 24. Okay, so just giving it a little more detail. And that's all we have to do about dot plots. If you get stuck or if you didn't understand something in the book, go ahead and review this video again.